I don't know why I wrote 6 down. It doesn't make any sense.
In your paper, you just
No, I'm crazy.
That was fun.
These are all straight lines.
Imagine if like everything was a straight line.
Whoa. Oh, man. That's positive.
Do we have to do the process for this? Or can we
No.
These things are relatively similar to colors.
It's fine.
This.
In most circumstances, we think it's more.
Okay, what's the interval from 2 to 5? It's just like 7.
21.
Yeah, because this is just like, duh. I'm going from 2 to 5, so there's 2, there's 5. So like my function is just the constant function f of x equals 7. And so this integral can just be interpreted as the area of this rectangle, yeah? Answer? 21. Woo. Is this function also a known shape?
Yeah.
It looks like
It's a triangle with a rectangle stuck on the bottom.
Triangle with the rectangle stuck on the bottom. Yeah, there's even a word for that.
Wait, Oscar, that's the next problem.
Yeah, that's the one we're on. This one, right?
Yeah.
Oh yeah, that's a trapezoid.
I had just like.
I'm very intelligent.
They just find
No, I genuinely just didn't forget that was a trapezoid.
Good.
lower.
Are you trying to be funny? Is an all-purpose insult, though?
I wasn't trying.
I know, but that made it even better.
What are you trying?
All right.
Just put this entire class on fire.
Good. Wait, hold on. You two, stop talking over there. All right, we get this purple shaped thing, which, as we have been discussing, is a triangle on a rectangle, also known as trapezoid. And like, yeah, man, it's a trapezoid whose like bases are 3 and 9, and whose height is like 3. Yeah.
Yep.
So then I think I know how to do this. Like average up the bases times the height. So that's like 18. Cool. Okay, cool. Cool. Woo. Okay, next one. A little bit more work is required.
Have the things that need attention.
Like drawing pictures.
Yeah.
So I think this is also like a shape. Yeah? Am I going too fast?
No.
Oh, there's an absolute value there.
That is an absolute value there. So personally, I'm just gonna know things about absolute value functions, which is they're like, you know, V's, and you just like move them to the right, and you get like zoom zoom, yeah? So what's the area? It's like 2 triangles. What's the area of this one? 2. And what's the area of this one? Yeah, 9 halves or whatever you want to call it. So it's like final answer, 13 halves or 6.5. Woo woo. Okay, good. The AC just went off. It means we have 5 minutes left. What is the integral from 0 to 7 of root 49 minus x squared? Yikes!
It's like half a circle.
That's a quarter of a circle.
Quarter of a circle.
Whoa, all right. Yes.
Oh, yeah.
All these people who are on the ball are saying, dude, I recognize this immediately. The square root of 49 minus x squared, that's a well-known parent function. It is the semicircle radius centered at the origin, radius 7, top half. And since we're going from 0 to 7, it is in fact just a quarter circle. You good?
Yep.
Woo! And I don't even think the limit process would work in this case because I don't have, we talked about this, it's like hard. But anyway, what is the area of this thing? It's a quarter of a circle, so it's like 49 pi over 4. Okay, this last one is the most important one of all. Go. It's like not totally obvious what the correct thing to do is here.
Why I felt like I shouldn't come today because I'm just so tired of like not actually being smart.
Good.
At least you didn't forget what a trap
Good, Oscar. Good.
Traps.
Alright, so let the record show that students are mumbling to each other, speculating on precisely what there is to do now. What makes this problem like kind of hard and weird and sort of new and causing you possibly some doubt? Yes, it's underneath. This is our first time dealing with functions which are sometimes negative. Are you feeling a little bit like, oh, panic, panic, what do we do?
Wait, just like stop by area.
He says go toward the x-axis and then what? So what do you think the answer is?
I think that the answer is -6.
Oh, wait, he knows things. I shouldn't have called on him. Or he just guesses right.
Wait, did you
No, I don't know. I mean, it's not obvious exactly what to do. Well, maybe it is. Yeah, what?
Like, clearly you're going towards the x-axis, but we don't know whether to add or subtract the part that's to the left.
Yeah, so someone give me like a coherent, you just guessed that you should just, yeah, okay, interesting. So here's one way we may do, can I just handle this? Okay, so here's the moment at which we realize that the concept of an integral, though like based on the problem of finding the area under a curve, in fact is not quite exactly equal to the problem of finding the area under a curve, and in fact sort of transcends that problem in a kind of way. Because if you go back to the Riemann sum definition, what are you actually supposed to be doing? What is an integral? It's the limit of a sum. And where does this sum come from? The sum comes from taking on each subinterval a sample point and plugging that sample point into the function and then multiplying the value of the function at that sample point by the width of the interval. And so if you should happen to plug your sample point into your function and get something negative, then that just means that f is negative there. And if f is negative, you're multiplying that negative y value by the width of the subinterval, and you're getting something negative. Do you feel it?
Yeah.
Okay, so these negative or these upside down rectangles contribute negatively towards the Riemann sum, because the Riemann sum is just the sum of a bunch of products of y values and widths. Cool? And therefore, what is the answer to this problem? It is in fact -6, because there's like -8 area like underneath, and then there's like 2 area over. Okay, the last thing I want to say about this is that this is actually what we want to happen. We want it to be -6, because what was the entire point of doing integration in the first place? What's one of our motivations was finding position. If this is a velocity versus time curve, then what does it mean when the velocity function is negative? It means you're moving backwards. When your velocity function is positive, it means you're moving forwards. So what is the interpretation of the integral from -4 to 0?
You move back.
It's how far you moved backwards. In fact, this shows that we moved -8 in the left direction, yeah? And then we moved 2 in the right direction. And so what is -6?
It's your net change.
It's your change, it's your overall change in position. It is your displacement. Precisely. Woo! Good. See you tomorrow.